Before we get started on today's lesson over rectangles, I wanted to talk about really quickly the relationship that exists between quadrilaterals and rectangles, which is what we're talking about today, and parallelograms. So quadrilaterals are going to fall into several different categories. If something's a quadrilateral, it can be a parallelogram. It could also be a trapezoid or a kite. We're not going to talk about those quite yet, but it could be one of those two. And if something is a parallelogram, it can be a rectangle. So I just wanted you to see this, that everything, the quadrilaterals can be parallelograms, and parallelograms can be rectangles. We're going to continue to come back to this particular diagram over and over again, and we're going to keep adding different shapes to it because we're going to continue to talk about different shapes. So it will help you to note that if you were going down the diagram, it is sometimes true. So quadrilaterals are sometimes parallelograms. Quadrilaterals are sometimes rectangles. Parallelogram are sometimes rectangles. But if you're going up the diagram, it is always true. A rectangle is always a parallelogram. A rectangle is always a quadrilateral. A parallelogram is always a quadrilateral. So anything that's true of a parallelogram must be true of a rectangle. Anything that's true of a quadrilateral must be true of a rectangle. Moving on to the notes, a rectangle is a quadrilateral with 4 right angles. So rectangles are always parallelograms. That's going back to the diagram. So if it's always a parallelogram, then everything that's true about parallelograms is also true about rectangles. Now rectangles are a little bit different in that the diagonals of a rectangle are always congruent. Remember, in a parallelogram, they weren't congruent. They did bisect each other. But the diagonals of a rectangle are congruent. If a parallelogram has 4 right angles, has a right angle, wrong word there, has 1 right angle, just one is all it needs. If we know it's a parallelogram and one of those angles is a right angle, then it's got to be a rectangle. And we also know that if the diagonals, we have a parallelogram, and the diagonals of that parallelogram are congruent, then the parallelogram is a rectangle. So this question says, what is true of rectangles that isn't true of parallelograms in general? So what makes rectangles special? Like, what makes them different from just a normal parallelogram? Well, the first thing is that it has a right angle. And the second thing is that the diagonals are congruent. Those are the two things that are going to make a rectangle a little bit different from a parallelogram. Skipping over to where it says page 19, if MNOP is a rectangle and angle MPN equals 50 degrees, then what is the value of X? Well, it requires a lot of geometry to actually figure this out. So we're going to talk about some various things that we can know about rectangles, because we know this is a rectangle. So this is a rectangle, then we know that this angle in the corner is 90 degrees, and we know this one over here is 90 degrees as well. We also know that the top and the bottom are equal, and we know the left side and the right side are equal. And because we know it's a rectangle, we also know that the diagonals are congruent and they bisect each other, so all these pieces are the same. So how does that help us? That's really the question, is why does that all matter? Well, it matters because we learned last semester, whether you remember it or not, that if two sides are congruent, the angles across from them are congruent. So if this angle is 50, then this one is 50. And I know you're still wondering, well, how does that help us? Well, in a triangle, which we have one of those, we have several of those, but let's focus on this one right here. If these two angles are 50, I know the angles of a triangle have to add up to 180. So that means if those two are 50, then this other one, I don't know what it is yet, I'm going to call it y. If I add them together, 50 plus y equals 180. Well, 50 plus 50 is really 100. So 100 plus y has to equal 180. So doing a little math, minus 100, minus 100, y has to equal 80 degrees. So this one inside is 80. You're still probably wondering, well, how does that help me? Well, one of the things we learned was that if this angle is 80, then this angle must be 80 because opposite angles must be congruent. So x must be 80 degrees. Moving on to the checkup. Number 1. If AC is 14, what is the length of BD? Well, AC is over here. This is a rectangle, so this one has to be the same, so it also has to be 14. Number 3, if AE is 26, what is the length of ED? I'm going to color that in black. Well, we know the diagonals bisect each other, so that means it's also got to be 26. Number 5 says if the measure of angle BAD equals 22, what is x? Well, we did a problem just like this a second ago, and whatever this side is, remember this one's going to be the same. And whatever this angle is, this one's going to be the same. So if that's 22 on the left, this one's 22 on the right. That means 22 plus 22 plus x has to equal 180. I can combine my 22's together, so 44 plus x has to equal 180. I'm solving, so I'm going to minus 44 from both sides. And I get that x must equal 136. Number 7, if BAD equals 40, what is x? Oh, this one's a little bit trickier, but we'll still figure it out. So going with what we know if this left one's 40, then the right one's 40. And I'm going to call this y in here. We also know that 40 plus y has to equal 180. If I solve, I'm going to add my 40's together. So 80 plus y equals 180. I'm going to minus 80 from both sides. And I get that y equals 100. So now I know that I'm going to erase y and I'm going to write in 100 there. So we're still trying to figure out how that helps us. Well, this one's 100. These two right here are in a half a circle together, which means that they are considered what we call a linear pair. So if one of them is 100, then the other one, when you add it to that, it must equal 180. So I can do some math and subtract 100 from both sides. And I get that x must equal 80. So as long as x is 80, that makes this a rectangle. All right, number 9. If CED is 62, what is x? So this time I'm going backwards. So if this one's 62, then we know the middle one on the other side is also 62. We also learned that the top left and the top right are the same. So if one of them's x, the other one's x. So I can write this time that x plus 62 equals 180. So I can change that to 2x plus 62 equals 180. Solving for x, which means I need x's on one side, numbers on the other. I can subtract 62 from both sides. So 2x equals 118. And then to get x completely by itself, I need to divide both sides by 2. And I get that x equals 59. And that would make it a rectangle.